Let's look at some derivatives of logarithmic and exponential functions with different bases. What we're going to see is that we can be really lazy now because we've developed the calculus for the natural exponential and the natural log, and we can simply change the base to have calculus for other logarithmic functions in differing bases. So for instance, let's look at these examples. We have y is the base 10 logarithm of 3x squared minus 5. Now, to do derivatives, you can go ahead and change the base and then do the derivative like you were if you were working with just the natural log. So the change of base would be 1 over ln of 10 times the natural log of 3x squared minus 5. Note what I've written here, change the base. And now this is just a logarithmic function. We know how to differentiate that. So we have y prime, we have the constant 1 over log 10, so we reciprocate the argument, 1 over 3x squared minus 5 times the derivative of the argument, which is 6x, and then we just push everything together, and we get 6x over the natural log of 10 times the quantity 3x squared minus 5. Just make sure that when you write your logarithm terms that you write them in a way so that it's clear what you mean. The natural logarithm of 10 is just the power of e that equals 10. So that's a number. You know that, but it's just good to make sure that your notation means what you expect it to. So now for number 2, we have y is equal to e to the negative x cosine x. Well, that's just a natural exponential, but this helps us utilize the chain rule. We know that the natural exponential is its own derivative, but when the power is different, we have to apply the chain rule. So no base to change, so we have e to the negative x cosine x, and now we take the derivative of the power. So I'll factor the negative, and so we need the derivative of x cosine x, so I'll put the prime here. So now I'll just go ahead and bring the negative out. So we have negative e to the negative x cosine x, and the derivative inside will be the product rule. So we get a 1 here when we differentiate, so we're left with a cosine x. And then, of course, leave the x alone and differentiate the cosine. We get a negative sine x for a term minus x sine x. And then, of course, you can just run the negative back through to make it look a little bit neater. So this will give us e to the negative x cosine x times x sine x minus cosine x. So again, very simple. All we're doing is using what we know about the derivative of the natural exponential and then all of the differentiation rules that we learned back towards the beginning of the class. Now for number 3 here, we have the exponential function 3 to the negative x squared. Now of course that's a nice even function, but the base is 3 as opposed to e. So what you can do, I've written a standard formula over here that you can use, just learn, or you can just change the base. So we can change the base to e to the negative x squared ln of 3 as we did up here. And now of course we have an exponential function, so we know how to differentiate that. Well, it's its own derivative times the derivative of the power. So we get e to the negative x squared ln of 3, and with the negative here like we had in the preceding problem, I factor the negative, and we need to take the derivative of x squared times ln of 3. Well, ln of 3 is just a constant, so when we differentiate, we get 2x ln of 3 and just move the negative out to the front. Now just to make it look pretty, of course, this here is just the change of base of this term right here that we started with. So I'll just write that as 3 to the negative x squared and bring all this other stuff up front and have the negative of the quantity 2x times the natural log of 3. And then of course that's multiplied by 3 to the negative x squared. So what you're seeing here is that the derivatives are fairly simple. Just make sure that you have your bases aligned in the way that you mean. And like I said before, if you compare this here, you can see that this formula here gives you exactly what we've done here. So you can make a choice when you differentiate these types of functions. You can commit to memory the actual formulas, or you can just remember the calculus of the natural exponential and natural log and change the base. It'll be your choice. And we are done.